Okay, so we're going to refine our skills on factoring. Now, I'm watching many of you work on the homework right now, which is great as long as you're already proficient in every method I show today. Okay? So, when we factor quadratics, first of all, we need to understand what we are doing. We are taking an expression, and all we're doing is rewriting it as a product of its factors. So we're taking an expression and writing it as a product of its factors. That's what factoring is. Now, step one in every single solitary factoring problem is to factor out any greatest common factor of all the terms in your problem.
2x.
Very good. So in this first example, the GCF is 2x.
You just said 2, that's wrong.
And when we factor out the 2x, what remains?
X minus 4.
X minus 4.
4.
Okay, you try.
Dropping the ball.
You try.
Wait a minute.
I would love to try.
Use my imagination, right?
No, you used your skills.
Square's not factor over half.
Have you ever watched Romeo and Juliet? I mean, I was just thinking. I don't do a lot of it.
Yeah, I know. I know, I have to redo that.
No, I mean, like, it was it's the one singing scene where they're on the side of the
Another 2.
Happy Life Ending. It's actually really good. I thought it was actually really
Okay. When we contemplate this expression, what did you find the greatest common factor to be?
4.
4?
AB.
AB. And when we factor that out, we are left with
5b
5b
minus 8a squared
minus 8a squared
plus 3.
plus 3. And that's completely factored.
C.
Okay? So, and both of these guys would be completely factored over the set of integers. Completely factored over the set of integers. So, when you see directions that say factor completely, basically they usually mean over the set of integers. So that each term would have integer coefficients. Fair enough? 5, 8, 5, -8, 3, 4, all those are integers, right? Alright. Okay, so the next type of factoring we're going to look at is a difference of squares. How do we know we have a difference of squares? Well, one, we have subtraction. That's where the difference comes from. And you have subtraction of 2 terms. And then the second part is both those terms are perfect squares. And I think all of you have at some point been asked to memorize your perfect squares 1 to 25. So that if I said something like 17 squared, you would all shout out
342.
No. 284. Wait, no.
259.
281.
17
It's
squared.
80s.
Okay, so we might
No,
need
289.
to polish up.
Oh, 289.
289.
Okay.
289.
I was pretty close though, just off by 100 or so.
Yeah. Okay, good.
I mean, I know the next one.
Oh,
I thought
good.
you said 17.
See, I said it was
You know that
confident.
21 squared?
Head.
Well, 21 squared, that is.
As he pulls
Pull
out
out
his
calculator.
calculator.
I'm doing it on my calculator.
Yeah.
21 squared?
As long as you say
Oh,
confidently.
600. Oh, wait. 21.
404. Wait, no,
441.
441.
As long as you say with confidence. it's right.
18 squared is 300.
Okay,
That's
so-
a fact. 400.
So those of you watching the video may also want to touch up on your perfect squares 1 to 25. That might help.
18 squared is
Okay.
24.
So if we had a difference of squares, it would factor to the square root plus the square root times the square root minus the square root. So in this case, x squared minus 16 would factor to The square root of x squared is x. The
Yeah.
square root of 16 is 4. So x plus 4 times x minus 4. Now, every year I teach this. Someone raises their hand again. Mine's similar, but it's a little different. I have x minus 4 times x plus 4. Is that right?
Yes.
Yes, it is. And we should celebrate that because multiplication is commutative. So, if all we do is switch the order of our factors, it's the same thing. Just like 2 times 5 is the same as 5 times 2. Okay, so if we just switch the order of our factors, yes, they're the
That's a
same.
pretty
All
bad
right,
example.
now, what would this one factor to?
3n plus 5m.
Okay.
And 3n minus 5m.
Excellent. Okay, now this one. This is a perfect square. It is a squared that is being squared. This is also a perfect square. It is 9 that is being squared. So this factors to a squared plus 9 times a squared minus 9. And though we factored, this is not completely factored over the set of integers because the second factor factors further. It is also a difference
So
of
just
squares.
A plus 3.
Whoa.
Yes. Okay, and so this is the completely factored form over the set of integers.
The first one can't do the same?
The first one doesn't. A sum of squares
It has
does not
to-
factor over the set of integers. Now, do you see? Are you catching on to the fact that I keep saying over the set of integers? Because we learned a new number system, that fabulous complex system. And could we write a complete linear factorization? Yes, we could. But we'd have to pull out some I to handle that. And we will, not yet, but we will. Okay? We'll get there. Alright, so now, for right now, and on tonight's assignment, you're only factoring over the set of integers.
Julian, it's not.
Okay. Now, the perfect square trinomial. This one we're already fond of because we know this. When we have that, we go square first, double the product, square last. Hey! Well, what does that give us? It gives us a perfect square trinomial where we have squared the first term. We have doubled the product of the two.
Oh my god.
And we have squared the last term. So it kind of undoes what we just did, doesn't it?
You actually.
Yes, you can actually do
So the last
that.
one would have to
Alright,
be-
so this one's a sum, but this one, because of the minus here, would be a difference.
So the bottom one.
Okay, so let's look at it like we might see it. Alright, so this is a perfect square, x. This is a perfect square, 4. The sign of the middle is positive. Now, when I'm factoring what I think is a perfect square trinomial, because the first term was a perfect square, and the last term was a perfect square, and it was 3 terms, I always try to see if it'll factor as a binomial square. But there's a check step. Every time I have to double this product, and does it equal the middle term? It does. Because some problems are sneaky, like this one. I'm going to sneak this one in here. Is the first term a perfect square?
Yes.
Yes. Is the last term a perfect square?
Yes.
So we might try to factor it like this. But when we double that product, do we get the middle term?
No.
No. Because this one actually factors to x plus 8 times x plus 2. Even though I had a perfect square and a perfect square, it was not a perfect square trinomial. Oh well. Alright, this, you check and see if this one is.
It's not. Wait, great to guess it is.
Yeah.
I don't have a pencil, so do it in my head.
Yeah, Miss Willoughby, Julian and I decided that one day we're just going to talk in Spanish for this whole class.
As long as you did it silently, I'd be just fine.
See, that's your bad part.
Asking questions.
Like, I was about to ask a question of how to use simplified Spanish.
Well, it's,
Probably should be ready.
what is your problem?
Alright, so if I square the first one, I get that. If I square the last one, I get that. And if I double the product, I get that. So yes, that's how it factors. Okay? So, now, I have 4 for you to try. They may not all work. They may. Okay, they don't all work.
Uh-oh, that didn't sound good. I'm gonna write it. Yes, better. My right one still messed up.
Seriously?
Yeah, it was weird. It's so weird. Like, close this side, can't see. Close this side. No, it's a mix. It's like. That's what it's like. These dudes really work. First, do at least. Let me see. Okay, so. The third one is not. Okay.
It's a trick.
Thumbs 5 is the same as thumbs 5.
Am I right or wrong?
How?
How? Because 6 times 4 is 24.
What?
If we double that, that's it.
Hold up.
48.
Yeah,
Square
good
plus,
job, Joe.
wait, what? No. What?
Aw, can I get a
Oh,
yeah.
Oh no.
You said home now.
So wait, would you just?
Yeah, you have to just get the
How? I'm
Because
so
if you
confused.
double the product, if I multiply these two, I
Oh,
get
I would
negative
just
6x, but if I double it, I don't get that. So this is as far as that one
What do you
can
mean?
go.
If you double the product,
Yeah, we did.
so wait, if you double the product, you can get 12.
So you just take the greatest.
Yeah, but it's gotta match
Can't
up.
get it.
The
But how would it?
negative.
But how would you? But would it have to measure to the first one and not that one?
Nope, you gotta go to right to the one right above.
That's just.
But we didn't do that for the first two, so like.
If I double the product, I don't get 24 either.
Oh.
I mean, if I double the product, I don't get
Okay, I don't get it.
I know. You're saying if number 4 and number 2 had a good coming back, then you
Yeah.
pull it out. It
If
doesn't.
number 3 had a negative 12, so I redid it right here, where it does have a negative 12, it would factor further, but it didn't.
Oh. This is how you
Number 4 is on the homework, almost exactly the same.
You know, there are lots of derivations of the same factoring that look really close, and I may have accidentally picked one that was on your homework, so. Alright, so this is a perfect square,
Pastel colors.
but this is not a perfect square. So, we would call this prime, which really means that it's a polynomial expression that is not factorable over the set of integers. It doesn't mean it's not factorable. It just means that it's not factorable over the set of integers.
Time 1.
Yes.
Would be good.
You have to be careful because we're about to factor stuff that you didn't know you could.
Maybe I want to see.
Okay, now this one. 1 is a perfect square. Can I write this is a perfect square? I can.
And wait, m to the third.
M to the third.
That's
So we could factor this as 1 minus m, 1 plus m cubed, 1 minus m cubed. Now, Monday, we're going to learn how to go further with this.
Why are we doing?
Yeah. So we're not going to completely factor this one. We're just going to get this one started. Little teaser. little teaser. And on Monday, we're going to finish this one up.
I'd rather not see the full feature film. I'd rather,
Okay?
I'm fine with
So,
the teaser.
you know what? I'll show it to you.
Did you hear
It's 1 minus m,
got a grocery store.
1 plus m. It's 1 plus m squared times 1 minus m plus m squared. There we go. Now this factors to that, and Monday you'll figure out how to do that. It's not hard.
I'm going to.
Okay, this one,
I want to know what she's doing.
GCF is 4. And does it factor further?
Wait.
Well, I haven't done it, that's
Yes.
why.
Yeah, it does.
It factors to 3s plus t and 3s minus t.
I hate using T.
I know, it looks like a plus.
And I write all my T's like
Like what?
Alright,
Plus parentheses.
like this.
okay, now,
Yeah, I already know you talked about it.
okay, so on these, it's kind of the reverse of distributing. We also call that FOIL. Okay? So all you have to do when you do this is you have to think, when I have a leading coefficient of 1, a quadratic trinomial with a leading coefficient of 1, all I have to do is ask myself, what do I multiply to get the constant that I add to get the coefficient of the linear term?
Oh, I knew this, okay.
Okay? What do you multiply to get -4?
4 negative 1.
Okay, +4 and -1. So if we do y and a y, this gives me y squared plus 4y minus 1y minus 4. Oh, it worked. Okay? What can I multiply to get -24 that I can add to get -2?
Negative 6, negative 4.
-6 and +4.
You were really close though.
So p squared minus 6p plus 4p. Oh, it worked. Minus
What
24.
are you doing? Yeah, okay.
Okay? What can I multiply to get 12 that I can add to get -7?
4 and 3.
4 and 3, but they both need to be
Negative.
negative.
Oh my gosh.
Okay?
Unnecessary.
That's with all you
At the end of today's lesson, I'm fairly sure I'm going to forward the YouTube link to some of your parents. And let them listen to your commentary. Okay? Yeah, some of you are fine with that. Alright, what can you multiply to get 16 that you can add to get 10? 2 and 8. Okay? Okay, you try. They all look very similar. They're all slightly different, and they all factor over the set of integers.
Oh, I need more paper.
You really write that down?
How many times does it look like that?
Oh, yeah, that does.
Alright. Those of you that are continuing to work on your worksheet, you're going to have to redo any problems where you showed work. You're going straight for the answer on all of them. So those of you that are continuing to work ahead, term splitting is not allowed. Okay? So you'll get to go back and redo those. Alright, so let's look at this one. This factors to x minus 15 times x plus 2. This factors to x minus 10 times x minus 3. This factors to x minus 30 to x minus 1. This factors to x plus 6 and x plus 5. Yes.
Where did we rewrote the problem when we pulled out the GCF?
Oh, GCF you got to pull out.
Okay, we're allowed to write that, right? That is-
Yes.
Okay.
GCF is fine.
No, it's not the first one.
Yeah. This is what I'm talking about. Okay? So, some of you learned to factor last year where it had a leading coefficient. Some of you may have been taught to use a box. Some of you may have been taught to multiply the first one and last one and get a number and then split that. And those methods work. And they're great for students that struggle in math. But that's not y'all. Okay? That's not who you are. So, what we're going to do this year is we're going to take off the training wheels, because that's what that method was. It was like training wheels to help you get through. Give you a little bit of help. We're going to take off the training wheels and just use trial and error. Now, Sam's already heard that in every second accelerated course, the last 10 years, all of our students have had to make 100 on the factoring by trial and error quiz. Which means you take that quiz over and over and over again until you make a 100. Okay? Now, we do this in lots of math classes from here on out. You've probably heard about the derivatives test in calculus. They do it there. So you'll see this, and we do it with skills that you must master to be successful after this. That's the only thing we're going to concentrate on. If this is a skill that you must attain to be successful in every math class after this one, that's why we do it. So, currently I have 12 different versions of this quiz. I haven't ever had to make more than 12. So I had one person that took 12 chances before they finally made 100. So you either make 100 or a 0. And if you don't make 100, you take it again. So if you miss one sign, you take it again.
Oh,
Okay? If you miss one
That's
number,
sketchy.
you
That's
take it
sketchy.
again.
I know it's like one
Okay?
sign.
But what it does is it forces you to practice, and practicing is the only way you attain skills. Like any of you that play sports, the only way you get good at it is if you practice. Any of you that perform musically, the only way you get good at it is if you practice. Same thing here. So, the practicing helps us to get better. Now, this method is actually easier. Yes, Carson?
It doesn't go into the grade book if you miss
The
a step.
zeros do not go into the grade book unless we get to May, whatever the last day of school is, and you haven't made 100. At that point, a 0 would go in. But I don't foresee that happening. No one has ever secured their 0 for the semester. Every semester, every year that I've taught this class, every student by the 12th quiz has made 100. Now, you can't use calculator and it's timed and you can't show any work. No calculator, timed, can't show work. The first 2 chances will occur during class time. And then after that, it'll either be a before school and after school, or I'll make arrangements to go to lunch and learn. Okay? Yes?
How many people get 100 on the first?
It varies. Usually 3 or 4 per class.
Okay.
Yeah. Okay, so trial and error helps you to factor by understanding what factoring does. Factoring breaks it up into its products. What is the only way we can multiply and get 5? 5 and 1. So we put a 5x here and a 1x there. So that if we were to multiply this back, we get 5x squared. Okay? What is the only way to multiply and get 2? 2 and 1. Now this is where we have to use a tiny bit of thinking. We want to place the 1 and the 2 so that when we multiply back, we'd end up with 11. Do you see if we put the 2 here and the 1 there, we get 10 and 1 makes 11. And because it's a positive 2 and a positive 11, we know we're multiplying to get a positive and adding to get a positive, so they both must be positive. That is trial and error. That's it.
Easy when I get this though.
Okay. All right. How can we multiply to get 3?
3 and 1.
3 and 1.
Just easy. Okay, 1.
How can we multiply to get 1?
1.
1 and 1.
1 and 1. Now we're multiplying and getting a positive, but we're adding and getting a negative.
Negative 1.
Okay, and let's check. That gives me negative 3 and negative 1 is negative 4. Yep.
Why did they teach for the first time?
Because we weren't educated.
I'm not sure. We have some different approaches to teaching. And with accelerated, this is the main method I would teach at any level. But there are different approaches. Willoughby's not always right, though I like to think I am. I am not. I do not know it all. That is for sure. Okay, so 3. 3 and 1. Okay, now, on this one we have to be a little more thoughtful because we know 2 is 1 and 2, but it's a negative 2, which means one of them needs to be positive and the other one needs to be negative. And we have to play a little bit. If I put the 2 here and the 1 there, that would give me a 3 and a 2. Would a 3 and a 2 make a 1?
No.
Yes.
Oh, yeah.
It will if this is a negative 2 and a positive 3.
I did that with my hands.
So that's 3 minus 2 is 1. So, factoring to me is like a cute little math puzzle. And I'm just playing around with the numbers. Testing my brain. I like it. It is. It helps you, keeps you a little sharp. Alright, so this one. We've got 2. Yay! Now I get excited anytime I see a prime number. Because prime numbers, there's only one way to do it. But when I look at this constant, it's not prime. That tells me this is going to be a slightly more challenging puzzle. Like the first puzzles might be level 1, this might be level 2. Slightly more challenging. I could do 1 and 15, or I could do 3 and 5. But I need a 7. And for me, I automatically know the positive 5 goes there and the negative 3 goes there. Because I know that 10 minus 3 is 7. Now, this is the beginning for you, so you might not see it that quickly. You may have to play around a little bit in your head to figure it out. But the 3 goes here, the 5 goes there. That makes 10 minus 3 is the 7. Okay.
10x minus.
You know how we,
have to,
yeah, because when we multiply, we distribute that one through,
Yeah.
and then we distribute this
So
one
you would
through.
have the 10x minus 3x.
Yeah.
Okay, I get it.
You get it? Okay. Now this one, I look at the first number and I go, ruh-roh, it's not prime. I can do 1 and 8, or I can do 2 and 4, and that's too many choices. It's a little overwhelming. So let's start with the last number this time. The last number is prime, so I know I got a 1 and a 3. And not only that, I know that both of these are negative. because I'm multiplying to get a positive, but I'm adding to get a negative. So this time I play around with those first terms. Is it 1 and 8? No,
It has to be 2 and 4.
it has to be 2 and 4, doesn't it? So I'm going to put a 2 right here and a 4 right there and test it. That gives me -6 and -4 is 10. Got it?
And we're timed?
Yes.
Oh god.
That's gonna be hard, the timing.
Oh,
Yeah.
That's just gonna be hard.
how many games is that?
I'll get this right.
Can we do that? Individually. What?
I don't expect you to be a speedster, but the reason I time it is so that you don't go back to this method. And I'm going to show you the method. Some of you did it as a box. Some of you did it like this last year. This method is totally valid. This is a valid method. This goes, this times this is this, and then we'd split that into 8x squared minus 6x minus 4x plus 3, and then we'd look at these two, and we'd pull out a 2 and an x, and it leaves me 4x minus 3. Well, this one I want to be 4x minus 3, but right now it's -4 and +3, so I better pull out a -1, and then I would group them, and I'd say, okay, so this gives me 4x minus 3 times 2x minus 1.
After a while, I just got tired of that and just started doing
This is so
Okay,
much faster.
so does this give you the same answer? Yes.
In longer time.
Is this our backup plan?
Yes.
Sure, it can be your backup plan. But for you guys, most of the time, you're going to be able to do this quicker, and it's less work. This is one line versus 1, 2, 3.
4 actually.
Okay? So, now this one is slightly more challenging, and I'll tell you why. 3 is prime, so we know it's 1 and 3, but we don't know which sign. We don't know if this is positive or -1. We don't know if that's positive or -3. Because it's negative here. They're different signs. So we're going to have to play a little more with this one. And so we're going to play with that 1 and the 8 and the 2 and the 4. And when I say play, I play in my head. I don't write it down. I'm going to play in my head. And my head's already figured it out. My head says, okay, you put a 4 right there, that makes a 12. You put a 2 right there,
That makes
a 2. I need that 12 to be negative
-3
and that 2 to be positive. And I'm done. Okay, so on tonight's homework, the only method I want you using is trial and error if there's a leading coefficient. Now, can trial and error be a little more frustrating at times?
Yes.
Yeah. If the leading coefficient has multiple factors and your constant has multiple factors, if both of them have multiple factors, it can be a little more frustrating. And at that point, I'm okay with you using one of those longer methods.
I don't remember now.
I still wouldn't, but I'm okay with you doing it.
I don't remember the longer method.
Okay? I'm not going to show you the longer method.
I forgot them.
Okay? So this one might take us a little more work.
Crap.
Okay, I'm going to try a 3 and a 2. And the reason I'm going with a 3 is to help me find some odd. I need an odd here. And that 3 might help me with that. Might not.
1.
116.
Well, 2 and 4.
How about the 8 here and the 1 there? And we'll make it a -16 and a positive 3.
3 minus 6. 3
3
minus
minus
16.
16 is -13.
That is -16 and positive 3.
Gives you that.
Yeah.
That works. You did that quick.
Okay. So, this one might have been easier for you to do that long drawn out method. It really may have. But I do want us to practice trial and error. And I do want us to become very efficient with it. That way we can be very effective when we get to higher degree polynomials. All right, you can work on your homework.